welcome you all. Today's discussion topic is solution of first order linear differential equation. What is first order linear differential equation? What is first order linear differential equation? If a differential equation is in the form of this, that is dy dx plus py equal to q, where p and q are both function of x, that is p equal to f1x, q equal to f2x. How can this equation be solved? This equation can be solved by using suitable methods. Suitable method is that if we make the left hand side of this differential equation a perfect differential, then this equation can be easily solved, that is easily integrated. Both sides are easily integrated. So our aim is to make the left hand side of this equation a perfect differential. How can it be a perfect differential? If we multiply this equation by such a function psi x such that this left hand side is a perfect differential. So we choose a psi x, and also this equation is multiplied by psi x such that the left hand side of this equation a perfect differential. We choose psi x such that the equation is multiplied by psi x and the left hand side of the equation become a perfect differential. Perfect differential. So we choose psi x, and also the differential equation is multiplied by psi x such that the left hand side of this equation become a perfect differential, and then we can easily integrate these equations and we get the solution of these equations. So we multiply this equation by psi x. Multiply this equation by psi x dy dx plus py psi x equal to q psi x. Now the left hand side become a perfect differential. So if we write in perfect differential form, we can write in perfect differential form, that is ddx of y into psi x equal to q psi x. Now if we differentiate y psi x, we get psi x dy dx plus y into ddx of psi x equal to q into psi x. Again we write this equation, we write the equations after multiplied by psi x on both sides. We have psi x dy dx plus py psi x equal to q psi x. Here these two equations are identical, that is they are the same equations. So it's we can compare the terms of these two equations. And after comparing the terms of these equations, we get comparing the equation 1 and 2, comparing one and 2, we can write y d psi x dx equal to py psi x, that is d psi x dx equal to p psi x. This can also be written d psi x by psi x equal to p dx. If we integrate these two terms, we get integration, we get c, that is log of psi x equal to px plus c, that is psi x equal to e to the power integration integration p dx plus c. So psi x equal to e to the power integration p dx plus c, that is a into e to the power integration p dx, integration p dx. And this psi x is called integrating factor. This psi x is called integrating factor. Integrating factor is psi x equal to a e to the power integration p dx. This is called integrating factor. So we put it in the second equation, that is equation 2, we get ddx of y psi x equal to q psi x, that is ddx of y a e to the power integration p dx equal to q psi x integration into e to the power integration p dx into a. So ddx y integration p dx equal to q psi x into e to the power integration p dx. Again, we integrate these equations. Again, integrating 3, integrating equation 3, that is integration equation 3, we get integration ddx of dx equal to integration q psi x integration p dx dx. So after integration we get y e to the power integration q psi p dx. This is the solution. This is the solution of linear differential equations, linear first order differential equations. Which is in the form dy dx plus py equal to q. This is the solution of linear first order differential equation. This is the procedure of solutions of linear first order differential equations. Now we can solve these three equations by using integrating factor, that is, these three equations are linear differential equations. We can solve this equation by this process. This process is using a uses of integrating factor. We can use integrating factor to solve these equations which are in linear form, which are linear differential equations. So we can solve the equations, first equations, which is x cubed minus x y1 minus this. We can solve it by the procedure of the solution of a differential equations, a linear first order differential equation. We solve by using integrating factor. Here, first we write this equation in linear form. That is, y1 is dy dx. Here y1 is dy dx. That is dy dx. So this can be written as dy dx minus 3x square minus 1 divided by x cube minus x into y equal to x5 minus 3x cube plus x divided by x cube minus x. This is in the form of linear differential equations, linear first order differential equations. Here p equal to linear differential equation, form of linear differential equation is dy dx plus py equal to q. This is the form of linear first order linear differential equation. So here p equal to minus 3x square minus 1 divided by x cube minus x, and q is this. Q is this. So integrating factor is if is e to the power minus dx. This is the integrating factor. So if we integrate this, we get minus integration d of ddx of x cube minus x dx. So this is equal to e to the power minus d x cube minus x by x cube minus x. which is e to the power minus log x cube minus x, that is e to the power log 1 by x cube minus x. This is the integrating factor. If we multiply this equation by this integrating factor, we get, if we multiply the equation dy dx minus 3x square minus 1 by x cube minus x y equal to x cube minus x, we get ddx of y into integrating factor equal to x5 minus 2x cube plus x by x cube minus x into integrating factor. So we have y into if integration is so integration d of y into if equal to into if dx. After integrating this, we get also we include a integration constant c. So after integrating this, we get y into if equal to integration by x cube minus x into if dx. That is y, if is 1 by if to the power log of 1 by x cube minus x equal to if is e to the power log 1 by x cube minus x dx. Now this is e to the power log this equal to this, that is y into x. If we factorize this component, that is x5 minus 2x cube plus x, we get x4 minus 2x square plus 1 divided by x cube, that is dividend is also factorized. We get, after factorizing the dividend, we get x into x square minus 1 into 1 by x cube minus x dx. X into x square minus 1 x into x square minus 1 dx. So x into x square minus 1 square divided by x square into x square minus 1 whole square into integration dx. This integration dx we get integration dx by x, which is plus also integration constant c plus c, so log x plus c. So we get y equal to x cube minus x log x plus c into x cube minus x, that is x cube minus x log x plus x cube minus x log c1 that is x cube minus x into log of x by c1. This is the solution. This is the solution. This is the solution. So we have solved these first equations in this way by using integrating factor. Now we solve the next equation, which is dy dx plus equal to this is the equation. Second equation is this dy dx plus sin 2y by x equal to x cube cos square y. Our first task is to this equation make this equation in a linear form. Our task is to make this equation in linear form, that is linear first order differential equation. We can use the substitutions here. We can firstly we divide the equation by cos square y, dividing the equation by cos square y, we get sec square y dy dx sin 2y by cos square y x equal to x cube sec square y dy dx plus if we simplify this term we get 2 tan y by x equal to x cube. Now we can substitute tan y as z. We substitute tan y as z, that is we put tan y equal to z. So sec square y dy dx equal to dz dx Now we put this relation in the equation, we get dy, the equation was sec square y dy dx 2 tan y by x equal to x cube. Now we put these relations in these equations, we get dz dx plus 2 tan y 2 into tan y is taken as z. Tan y is assumed as z, that is 2dz by x equal to x cube, that is dz dx plus 2 by x z equal to x cube. Now this is in the linear form of first order differential equation. This is linear differential equation. Here dependent variable is z, independent variable is x. So this is linear first order differential equation. We have already known the solution of this linear first order differential equations, and we also use here the integrating factor such that by which we solve these equations. Using integrating factor we can solve these equations, and that is integrating factor is e to the power p dx. Here p is 2 by x, q is x cube. p is 2 by x, q is x cube. So integrating factor is e to the power p dx, that is e to the power p. p means 2 by x dx. If we integrate this, we get e to the power 2 log x equal to e to the power log x square equal to x square. If we multiply these equations by the integrating factor, we get d dx of multiplying by x square, multiplying the equation 1. The equation 1, multiplying the equation 1, we get d dx of z into integrating factor equal to x cube into integrating factor. So we can integrate these equations. If we integrate these equations, integration d dx z if integrating factor equal to x cube integrating factor dx. Here integrating factor is x square, that is z x square equal to x cube into x square dx. So after integration of these equations, we get integration of d dx of dx, integration here also dx. So after integrating this, after integration of these equations, we get z x cube x square equal to x5, integration of x5 dx is x6 over 6 plus integration constant c. So So Z equal to x4 by 6 plus C x to the power minus 2, and also Z equal to, we have already chosen Z equal to tan x. So tan x equal to Z equal to tan y. So tan y equal to, this is the solution. This is the solution. This is the solution. This is the solution of second equation. We have solved the second equation by using integrating factor, the procedure of linear first order differential equation.